Yes, so apologies. I still have to set up a bit. I've wasted so much time now to trying to get into the correct version of Teams, which I failed to do so, and that I'm now a bit behind in setting up. Right. So I think that should be it now. Anyway, let's just get started.
Okay, welcome to the 5th lecture of COV 885. So, Mr. Volker, please take over. Continue.
Thank you. So I'll just wing it today. Right. So what are we going to talk about today? Let me. Right. So let's just have a think about where we were up to the last lecture. So we were looking at documents in general, how documents contain semantics, and that the semantics is important in order to make them accessible. And we were thinking about how to get these semantics to bridge this gap between the document source, if you like, and its printed version, which doesn't really contain much semantics, and the web version of a document, which then will be able to contain a lot of the semantics that the original author might have put into that document. And the way we were working on in the last lecture, we started actually working on math documents. We looked into, how can we get them across from their original source, primarily LaTeX, but also Word documents that then can be rendered online, and how does that rendering work? So we started looking into the MathJax library, and this is pretty much where we're going to carry on today. So today we're going to talk about MathJax. That's misspelled here. That's supposed to it's not MathJax, but MathJax. And also how accessibility can be achieved using a MathJax, and as well as its extension for particular for accessibility, and how that actually is incorporated by trying to get semantics into the page. And that will then set the scene for talking further about what is really semantics in a web page, and how can we get that for more advanced content, in particular STEM content. Right, so let's recap a bit what we've done last Wednesday, which was primarily based on rendering on mathematics for the web, and then and we've started looking at two particular converters. One was Pandoc, which we saw was giving us a fairly accurate and faithful conversion of a LaTeX document in what we would expect it to look like in print. We also saw how we could then kind of get to a more web style version of the document by removing some of the styling in order to make it reflow, etc. The other converter we looked at was Make for HD, which generally is a bit more reliable when it comes to converting LaTeX documents, because it really lives in the LaTeX environment and has access to the entire LaTeX ecosystem in terms of the style files, etc. Whereas Pandoc is kind of the Swiss Army knife. It can convert from one document format into the other, and I'm not quite sure. I'm not sure whether I've showed you the Pandoc website actually, but let's just have a quick look at Pandoc just for the fun of it, because there's a really nice picture on it which should give you an idea of what it is actually capable of transforming. So these are all on the left-hand side. So this is a ginormous graph for those of you who can't see the website, which relates the input formats to the output formats Pandoc can do. And on the left-hand side, there's about, what is that, about 15, 20 odd, or more than 20 input formats. And on the right-hand side, there's about twice as many output formats. And it can transform from all the input formats and all of the different output formats. And that's why it's called the Swiss Army knife of conversion tools, because it can pretty much do anything you want to convert. And it does a fairly reasonable and good job. When you want to have it slightly more advanced content, then again, particularly when it's LaTeX content, then it is a better choice to use something that's directly in the LaTeX family. So Make4HD or Tech4HD is generally a better choice. Anyway, so that's just to set the scene. And then we were looking at math checks and how math checks, we saw already how math checks can render the math online. And I would like to just stress that math checks is not the only solution that can render math online. There's a couple of others. One is KTech, which particularly can work. It has been created by Khan Academy. Primarily, it exclusively works with LaTeX and cannot use any other input formats. It produces a fairly rapid SVG output. It does not implement the full text layout algorithm as LaTeX as MathChex does. That's why, for instance, MathChex is generally the choice of all the publishing companies, whereas KTech is kind of, something for rapid prototyping is definitely useful. MathQuill is another one which seems to be a bit defunct over the last couple of years. I'm not sure whether that's still being developed. Another version is MathLife, which is primarily aimed at interactive documents. So if you actually want to input things into your page, and then it renders very nicely snippets of your input and is quite fast. As in terms of, just to point this out, in terms of accessibility solutions, MathChex comes with an accessibility solution. So does MathLife. The interesting thing is that the accessibility solutions behind both is the same system, and that's a system I'm creating. I'm working on, which is called Speech Rule Engine, and I'm going to talk about that in more detail later on in our lecture. Right. So we've already seen how we've seen so far how Pandoc and Make4HD automatically include math checks into your website or into the converted document when you give it the appropriate option, right? So in Pandoc, you give it -- math checks. In Make4HD, you just give it math checks in quotes in the command line. But if you don't do that, you can still make the whole thing accessible with math checks, or renderable with math checks, or any document, as a matter of fact, if you just give a particular script line, a script tag at the beginning of the document, which loads math checks from the content distribution network. So that's, in that case, there's a bunch of different pre-compiled libraries in the cloud, if you like. In particular, and that one is JS Deliver, which allow you to work with different input and different output formats. So for instance, this one here I've put down is, you can see that the end of the string here is tick MML CHTML. What does that mean? That says, well, it can understand tick and MathML input in the page, find it, transform it, and the output will be CHTML, that is CSS styled HTML. So other alternatives, for instance, are instead of CHTML, you could have SVG there, which will give you SVG output. You can specify, or you can narrow down the tag further by just say, or the input, but just saying tick, or just saying MathML, and so on and so forth. So all of these are documented in MathChex documents, so it's easy to find. Right. So for those of you, since I'm not sure whether we're going to try breakout rooms again today, because so far we haven't really been successful, and I've still logged in with the wrong account. So we might not really do that today. So let's work as we have done in the previous lectures. Either I do something here on the screen, or one of you can share their screen. So I think I've put these. So these are the documents that we had created. That's our math example that we had previously. One is done with Tech4HT, and the other one was done with Pantoc. So I've put all of these online just in case you want to work along. And not quite sure why this one doesn't work. Oh, because I've already made changes to it. All right. Right. So what we're going to do now is we're going to start learning about how you can actually do some changes to the maths document after you've already converted it. So why is that important? First of all, because it's important in order to adapt it to whatever particular visual output you might want to have. And secondly, it's important in order to see, in order to customize the document, but for, say, for accessibility, but also for other things. In terms of display, in terms of certain elements that you might want to run in the pages, and so on and so forth. And what you can do is in your MathChex or in the web document that you get, you can include a script tag. And oops, there's a typo. You can include a script tag which gives MathChex a particular configuration. So one thing, for instance, that's always important is to tell MathChex what is the inline math, for instance, that you can use. What type of mathematics can you use for inline math? So in general, as you might know, LaTeX uses single dollar signs, so you have inline math. So inline math meaning that this is mathematics that just occurs inside the text rather than offset in a separate environment, in a separate paragraph. Now, by default, MathChex doesn't know what to do there, unlike LaTeX, because dollar signs are fairly common on websites, and you don't want every dollar sign to be interpreted as a potential math environment. If you tell MathChex with a particular configuration option, as I've given here, so that just says, well, MathChex configuration MathChex equals open parenthesis, so it's a nested dictionary environment, and then you tell the TEC, particularly the TEC parser of MathChex, with its options inline math, and then you can give the start and the end elements that it should look for in order to find inline mathematics expressions. Right, just to demonstrate how that you can also see this all of this you can find in the MathChex documentation, which is very extensive, and it's continuously being updated. And David is doing a great job at updating that every new point release. He updates the documentation. I occasionally update things about the accessibility features, but I'm not quite as good in updating documentation as David is. Right. So now we're going to work through the first example, which is an important one because that often occurs in certain texts, and that is the question of how do we add macros. So for those of you who are familiar with LaTeX, and I've seen from the surveys that many of you are, one of the great features about LaTeX, and one of the features that's used by most authors and sometimes even abused by many authors, is the possibility to generate macros. Right? So you effectively, LaTeX allows you to implement your own little extensions that you can then use in the text in order to shortcut particular expressions. Or if you use something very often, you don't want to have to type that out all the time. You might generate a macro, and that macro you can use at those places. And obviously, there's various ways of using macros within MathChex and within web pages that contain MathChex. One way is to tell it to the entire document how to use that. And I would like you to, if you play along, and there's an example file which you can download, and I'll do that which is using which is a very trivial, you can also just copy it out of here if you like from the slides, which all it does, it uses the slash command. Now the slash command is a very recent addition to the LaTeX corpus, and for some reason it hasn't been implemented in MathChex yet, and therefore it has to be added as a new macro. Now let me just start playing through that, and then let me hold on. Can you still see me? Can you see my terminal here?
Yes, I can.
All right, very good. Let me make that a bit larger so you can see it a bit better. Right, so I've got the slash document here, right? It's exactly the same as we had on the website, and if I just run that, say with pandoc, output slash.html, and we call it we did standalone with MathChex, right? Then I'll shoot that up in a browser. All I get is the slash command, and as you can see, it's red here, meaning that the slash there is just it's unknown, right? LaTeX does not know how to use that slash command. Now there's a couple of ways how to not LaTeX, sorry, MathChex does not know how to use the slash command. It doesn't have a translation for it. Now there's two ways of effectively getting that command in there. The one is the commonly used way of doing this within LaTeX, and that is kind of using a new command environment, and not environment, and a new command. Simply a new command, sorry, which defines the new macro. Let me make this a bit larger so you can see what I'm typing, and I think that's also on the slides. Right, so here it is. So one way of adding a new macro is simply by using the new command, which is exactly what you would use in your LaTeX document, right? So this is the bit which you would have in your LaTeX document. Let me copy that out. Let's go to the LaTeX document. Let's see what it does in there. If I copy that in the preamble of the LaTeX document and I LaTeX the whole thing, it tells me that it's already been defined. Sorry, so we probably have to use a renew command. And then it does work because LaTeX already knows slash, and therefore it works. Right. Now let's do the same thing in our web document. Now let's just copy the new command in there, and let's see what happens. Where's my slash document? And nothing happens. It doesn't like it. Right. That's a bit of a nuisance. Did I save? No, I didn't save. There it is. Oh, right. So that's not good. Why is that not good? Well, I've copied the command in there, but MathChex can't see it. Any reason why MathChex can't see it? This is a question to you. What do you guess? Why can't MathChex see that? What have I done wrong? Do you have a guess?
Do we have to give it into a correct format, maybe JavaScript?
No. Any other reason?
Because I think MathChex still don't know this macro.
MathChex doesn't know the macro. No, also wrong.
Okay.
let's think back a bit. What does MathChecks do? Think about the web document. So that's the web document. It's being rendered. Right? So here's some text that's being rendered on the screen. And here's some math that's being rendered on the screen. What does MathChecks do?
For it is still HTML. It is not into LaTeX.
Let's have a look at. Can you see my Emacs here?
Yes, we can.
Okay. What is the difference between this line and this line? Okay, if you think this should be better HTML, let's put a div around it just for the fun of it. How does that look? What's happening now? Nothing. So we've now put it into a proper HTML element. Still doesn't want to do anything. Why not?
It should be in LaTeX format. For
What
an
does that mean?
dollar.
Well, yeah, let's do that. $sign, you think? Oh, well done. So why is that?
Make it,
yes?
To make it understand that it is a LaTeX inline maths. But we have a $. That means it is not inline, it is display maths.
Well, it doesn't really matter, does it? Because it's not displayed anyway.
Yes.
So if I give it a single $,
then I think it will not work.
And it won't work. Why won't it work now?
Because that is not defined to consider as an inline math operator.
That's right, but didn't we just say we know how to do that? Let's do that then. All right, so let's go back on our slides. And here was the way I've defined inline math. Now here it is, right? Well, let's enter that. Let's copy that into our file. And this is the important part that has to be copied in there before, well, let's complete the script here, before MathChecks is being loaded. Think about it this way. MathChecks is being loaded in the page and starts looking where there's a configuration. If the configuration is being evaluated after MathChecks has been loaded, it can't find it. Therefore, it always has to come before the load command. Now it's in there. Now let's see what happens on our page, on our slash page. And now it works again. Right. So what are the things that we've seen here? Now, first of all, we've seen how we can enter this little script command in order to this little script tag in order to configure MathChecks. But we've also seen that we can enter this little new command thing inside a math environment. Now, the important thing is that everything you want to tell MathChecks has either to come in the configuration or somewhere in a mathematical environment. Because all MathChecks can do is it looks through the entire page and looks for everything that's in a math environment, and then it does something with it. Everything else it just leaves alone. So obviously you don't want to mess it. You don't want it to mess with any of the other content. All you want it to do is work with the math content. As a consequence, unlike in your LaTeX document, in your web document, your new commands in similar commands all have to be in a math environment, even though you can't see them, right? So you can only see them if you do them wrong. If you do them right, everything is fine. Right. Right. So that was. Let's head back to the proper slides. Right, so that was the way how we can generate macros. Now that's one way of doing macros, right? So this is the way of adding the macro in your new command. Now there's a separate way to do this, and as I said, there's two ways of talking to MathChecks. One is in the math environments, and the other one is in the configuration. And we can do the same trick in the configuration. So here you can add macros, whatever macros you want to have for the entire page in the configuration. and then it will be picked up automatically by MathChecks. It will be registered as a command, and then it will be applied. Let's try doing that. So let's just copy this bit out, and let's put that into our file. So we've already have the configuration for tech in there. So all we have to do is now add a macro configuration. That looks ugly. So I'll do the spacing a bit better. And that should do the trick, right? Let's get rid of this part here, just so we see that we really are using the right element here. Right. Now we have the same thing in there. And just to demonstrate that we've really done something different, let's just change that, put X's around it, and see what happens now. And yes, indeed. So this is really the macro we've just created that's being picked up, how that's being picked up in the website, right? Now, just for the fun of it, so this is the first version. Let's have a second version of it, right? So the second version is the original version, which we now introduce as a new command before the second display. So what we get now is, well, at this point, the macro is the one that's being picked up from the configuration. And at this point here, it will be the one that's being overwritten with the new command. Now, can anybody still see a problem there? Something is still pretty ugly what I've done. Can you see the spacing between these two elements? So what I've done here, and this is quite ugly, I've introduced this new command here with in its own div. That means it generates really visual output. Let's try to change that to a span, just for the fun of it, and see what happens then. That still doesn't make a difference, right? Still makes the same visual output. So what else could we possibly do? Well, let's try to put that new command actually in with the next one, with the next mathematical command, and get rid of that span. And let's see what happens then. Well, now it looks a lot better. All right. Well, that just means that we're taking out superfluous space. So although the new command is not displayed, this particular visual HTML element will still be rendered by the browser. So you have to be a bit careful where you put these things in. If you put them into the configuration, that's always good, because that means it has nothing to do with the actual HTML. It's purely on the JavaScript basis, meaning that you will not change the visual rendering of the document. If you put them just anywhere in a span, that might have effect on the visual rendering. Right.
Volker, sorry, but I missed. Why did you say that the second macro that we have inserted is not, it does not have the X. It is overwritten. How?
Yes.
I did not understand that part.
Right. So this is about the flow of the document, right? So what is the order of the document? The order of the document is, if you look at the document, we have an H1 command here. Then we have a math environment there. In that math environment, the MathChecks is running with its original configuration. That configuration comes from the configuration that we put into that script tag here, right?
Right.
So this is the one with the x\x.
Right.
After that, MathChecks processes the next math element, which is the one which first the new command. So now that means it overrides the slash macro with a new version, which is just the pure backslash. And then it outputs that. Let's just, just for the fun of it, let's enter yet another one. Let's just call that XYZ. Just let's see what happens now. Oops. Nothing happens. Why not? What's going on here? Ah, yes. So this is I think we have to do a renew command on it then. Yes, now that's it. So, right. So this is now the LaTeX version, right? So in LaTeX you have your new command, and once it's defined once, you have to redefine it with a renew command. Right? So what happens now is let's put these side by side so we can actually see what's happening here. Mathsjax goes in, renders the first version for this slash command. It looks up the macro which it has received from the configuration. Good. Then it goes to the next one. It processes this new command, meaning that the original slash will be overwritten by backslash.
Got
This
it.
comes out. It goes further. It renews the slash command again, overrides it with this bogus XYZ. And therefore A/B now becomes AXYZB. Right?
Yes.
And you can do that further and further and further. And then it's the workflow is exactly as you would have, say, in LaTeX. And similar as you would have in LaTeX, for instance, you can do things with for instance, oops. Yeah, that's my slide. Sorry. So you can do the same thing with new environments. For instance, you can use a new environment in your command and generate new environments. And there's an example of a new environment. And this is in the process of changing this. Oh, we're not in the process of changing it, but adding the feature that you can actually now start using those environments in the configuration as well. Well, that's a fairly new feature. And that comes out with the next point release, which was supposed to come out at the end of March, but now it's already mid-April. So let's hope by the end of the month it will be released. Right, so this actually was supposed to display properly, but clearly I've made an error in the slides. Sorry about that. But if, just let's, because we have a document running already, let's just pop it into that document and see what happens on this one. Right, so this is a new environment, right? So there's an environment called braced. Just puts braces around whatever element you give it. So if I were to take this out, well, let's just for the fun of it, let's take it out. It tells me this is an error, right? So it returns the unprocessed element, and then if you hover over it, it also tells you the error that it has received. I'm aware that not everybody can see the slides, and let alone the hovering. So what it says on the hovering, so this is the environment is called begin braced and end braced. Braced is not a known LaTeX environment. And now when I hover over it, it tells me unknown environment braced. If I add this piece of braced in here, so I add now a new environment braced with the left and right definition for the start and end definition for the environment, which is just the left brace and the right brace, and I run the thing again, then I get the full correct output. And it's nice and there, and left and right braces are stretched, so they encompass the entire expression they fence. Right. Oops. Where are my slides again? Yeah, they are. Right. Right. And well, okay. One thing before we take a short break is what I wanted to point out. There's a couple of differences because we were talking about Pandoc and Make4HT. We already looked at some of the rendering differences last time. When it comes to Mathsjax, there are some additional differences which are important for people to notice. So the things that what I've just been working with. Yes.
One question. So when you're using it with Pandoc, and you're also doing a conversion from one document style, then one format to another format. At And then when you are giving the pandoc, so this when does it go to matchjack? After conversion or before conversion?
After the conversion. So all pandoc does is it puts in a minimal configuration for math checks. That is effectively no configuration and just the script that calls math checks into the website. That's all pandoc does. So what it does in particular is it leaves all the LaTeX it finds, all the math it finds alone.
Okay.
And kind of postpones to whatever rendering engine you tell it. Right. You can also give it, for instance, KTech. In our case, we now give it math checks, and when you give it math checks, then all it does is insert this script tag, and then the actual math rendering is being done by math checks in the web page. Does that answer your question?
And matchjack will only look at all the maths, declared maths within that document, and it expects to be in LaTeX type.
Yes. It could be in MathML style as well. Could be in MathML.
Okay.
Could be in ASCII math. Depends on where the original math comes from. So what effectively what pandoc does, as soon as it finds math in whatever format you have given it, and you tell it you want to use math checks, then it just leaves it alone. All right. If you don't tell it math checks, then excuse me.
Matchjack will automatically be able to
yes.
Work out whether it is LaTeX or whether it is MathML, and then
yes, yeah, and it takes those elements and it renders them in whatever output you've asked it to do. Now, but the question is very fitting, because I want to very briefly before the break point out some of the differences between these the configuration that pandoc and make for HD does. So pandoc, as I said, includes a minimal math checks configuration. So effectively all it does, it includes elements that it includes a script element that loads math checks, but it doesn't include any other configuration. What it tries to do instead is it tries to, as much as possible, destructure macros and rewrite the macros. Right? Make for HD does the opposite. Make for HD tries to understand as much as possible what is necessary to let math checks work, and puts in a fairly detailed configuration. And I'll show you what the difference is with this example of the our environment. I should have that here. Braced tick. So this is just an example. Let me make that a bit larger. So this is the LaTeX example that I've showed you. That is that contains a new environment which just braces around an element, and it's defined here with new environment as a macro. And I've put together, I think I've put two translations together. One is this pandoc. That's this one here. And I should maybe just load that straight into the page. Can I see that here somewhere? Right. So this is the original praise. So this is how we want it. This is the pandoc translation, which without doing anything to it works straight out of the box. And I'll show you why it works straight out of the box. And this is the one with the with make for HD, which tells you it's an unknown environment braced, right? Which is pretty much what I would have expected. Now, what is it pandoc does? Well, if we look at the pandoc code, and this is the translation of pandoc, what it actually has done is it has destructured the macro and tried to put some of the pieces of the macros into the right places. So it actually puts the left and the right brace in the right place, straight with the conversion. So it tries to resolve the macro. This works sometimes, unfortunately not always. Right? So it tries to do something clever, which sometimes works, but not always. Now what Tech for HD does instead, I think that's the other one here, MK, yes. Let me make that a little bit larger. It's a bit uglier to look at, but what Tech for HD does, it inserts a MathJax configuration environment, which is fairly detailed. So it tells it, what are the inline math elements. It tells it what to use for display math. It tells it a couple of other things it should process. It also tells it all the packages that it should use. Okay? So now the interesting thing here is that it does not include the macro definition, and it also does not include and it also does not try to resolve that macro definition. So let's just enter that macro definition. There it is, our new environment. Let's add that here so MathJax can actually see it, and let's see what happens in our example. Let's run it. Now it tells me, oh, undefined control sequence new environment. Well, that is a nuisance because new environment is clearly something that we want to have. Why can't make for HD see that? Well, this is fairly easy to see, and well, it's easy to see for the initiated. I understand that not everybody can see that straight away. So let's have a quick look at these configurations. So there's configurations for tags, for inline math.
Just 1 minute. So you did enter this in the source, this new environment. So what you're saying is, Matt, this just ignored it?
Yes, it can't. It doesn't. No, the MathJax. So the problem is that the MathJax currently being loaded doesn't know what new environment is, and I'll show you why. So let's have a look at here are packages. Packages, how they're being loaded, right? So this is these two lines.
So the reason it worked is only the macros were expanded by Pandoc.
Yes, by Pandoc macro, the macro is being expanded.
Okay, so all the places it just get copied, so it works.
Yes. So effectively, it copies the left and the right. It doesn't work as soon as things are nested. But that's a different story. So what happens here on Tech for HD, it really works out what packages MathJax needs for that page, and it works out a minimum configuration, which in some way makes it very lightweight and a lot more flexible than Pandoc. On the other side, when it comes to things like new macro definitions, something is missing. So what actually is missing is the new command package. And I know, of course, that the new command package exists, so I add that. And let's try to load that. And it probably doesn't need to be loaded explicitly, but let's see. Let's have a look. And all of a sudden, it's there. So that's the problem with Tech for HD, that it actually knows. So there's two different approaches to this. There's the Pandoc approach, which tries to work out intelligently how to destructure and decompose the macros. And there's the other one, the Tech for HD, which tries to be smart about what packages to include. We can see neither is, ultimately, when things become very complex and complicated, one will eventually have to go into the configuration and start messing about with that. And that's pretty much what I wanted to show you before the break. And after the break, we'll start on making all this, what we've just seen, accessible. And I'll see you in 5 minutes.
Okay, good.